Alright. I think I see the vision now. I see the vision. Oh, you can, let me put it right next to the heater right here. I hope it picks all that out. Actually, let me put it, I don't know. Maybe, I don't know where I should put this. Because I'm not on my computer, I'm on my phone. I've got ATAC 1.5 in front of me, the notebook. Where should I put the phone? How about this? I just moved this rock. Right? Right here. I put the phone on top of it. Okay, that should work just fine. But, okay, now, Phaedrus, what is it? 52736. Well, number 6, right? What's it called? Now I'm trying to decide between tuning and jumping. So, Knights and Susians has jumping, right? How it works is you hold up J. You know, it's what's it called? What is my name? It's a J in ASL. So, I was going to say, so yeah, it looks like this. Look. Yeah. But you hold that up, then you jump to whatever plane you want, but it can't be the same plane that you're in. The way tuning works in the Claire calculation is you basically hold up the same symbol, except the only difference is that, well, it was supposed to be the same symbol, but if you have a UI, like, you know how in Sword Art Online they have that like little menu that they can bring up when they like bring their finger down? There's a UI like that for SoulNet, for images, right? And you're supposed to be able to see the address you're jumping to before, or I guess the frequency, before you actually jump there. That's like the difference between jumping in Knights and Susians and tuning in TCC. But what was I gonna say? But there are some very small differences. It's like tuning sort of behaves like, I was gonna read this from earlier. Behaves like NI's jumping, where you imagine where you want to go. The only difference is that with SoulNet's UI, you see and cement the exact numerical frequency in your mind and then tune/jump. Like jumping, tuning only works vertically, and that's true. Like you can't jump somewhere in the same plane in Knights and Susians. You have to always jump to a different plane. That's why it's like whenever you see characters or groups try to go somewhere, they have to hop somewhere else first and then to the position that they want to in the same plane, if they want to go somewhere in the same plane. For tuning, you have to do the same thing. Like if you want to walk from one point to another on the same frequency, you have to actually walk there. But it's like, oh, well, if you use that jumping logic, then you could tune to some other frequency, since you are being teleported, if you want to call it that, horizontally, right? Like, do you have to be right under, like, imagine, okay, for tuning, I want you to imagine a giant 3D cube, right? I want to make this easy to understand. And you have your X, Y, and Z axes, right? So let's say you're at, I don't know, 444, and your friend's house is at, well, I need to write this down. I need to follow along with this. So you're at 444, for example, right? And you have someone that's at, I don't know, 447, right? They're at frequency number 7, right? The XY is the same. It's in the same place, but their house is directly above you by 3 units. In theory, oh, well, I guess if it's right above your head, right? If their place is right above your head, then you should be able to tune to 447, your friend's address, and then be there, right? But let's say you're not at 444 and you're actually at 222, right? You're at 222 now, and your friend's house is at 447. Well, it's like, okay, well, if you tune to frequency 7, you'd have to tune the other frequencies at the same time. And so it's like, okay, well, how is that supposed to work? I would think now, okay, now I'm kind of starting to see the vision. Hashtag Friday 17. Or no, 27. Not 17. Not 17, bro. Throw that shit out. But now I'm starting to see the vision, because it's like, okay, well, if it was a frequency, it can be represented by a decimal. I don't know, a number with a decimal in it, whatever. Dude, I graduated, okay? I'm not supposed to be in school anymore. But 4 digits in front of the points or whatever, and then 4 digits after, right? And so I'm like, okay, well, how can I represent 3D space using just these 4 numbers? And that's what I want to figure out now, because I don't want to get rid of the tuning system. I like it because I'm able to create exact addresses that reference characters directly. Like for Lady Almothea's mansion, the frequency for hers is 400.76. And that if you use NI's number pad, anytime you're going to see a number, anytime you see a number throughout my series, always try to convert it using a number pad. Like you text people back. If some of you are old enough to remember texting people back in the day on those phone pads, right? And you have to keep hitting the same thing to get your caps and your lowercase and different letters and whatnot. Try that. I think it's just easy to ask ChatGPT, say, hey, these are my numbers. Does this spell anything? But that's what you have to do, right? But it spells out horn, which is inspiration from the actual Almothea that raised Zeus. Because I think she had some kind of, I don't even remember the story off the top of my head. I was going to look for it. Like some kind of mythical goat horn. The goat nurse of Zeus, in Greek mythology. The stories are kind of different. It's why it's kind of weird, depending on where you read the thing from. But the one I want to mention, as early as the Archaic period, there exist references to the horn of Amalthea, a magical horn said to be capable of producing endless amounts of any food or drink desired. Yeah, like the one with like the goat and all the other stuff. It's not supposed to reference that. It's just supposed to reference the fact that she's raising Zeus, and she has this tool that can basically do anything, right? And that's Integrator. So I'm like, oh, that would be perfect. A perfect kind of reference. That's where Lady Almothea gets her name from. Now you know. But anyway, right? Going back to tuning, it's like, okay, well, 4 places in the front of the decimal and 4 behind it. How can I represent? And then it's like, okay, well, how big is Solna? Is huge, right? And if we're imagining that 3D cube like before, we know that our z-axis goes from 1 to 1000, right? And so how are we supposed to represent that with a decimal? That's why it was 4 digits, because it's like, okay, well, what's it called? It can only go up to 1000. So the 4 in front, the max value for that would be 1000. Okay, so how about the x-axis and the y-axis? I don't know. So then I was like, okay, well, it's already, this whole system is already pretty unique because I'm using the what's it called? The non-existent Hanzi from Claire's, or not her subtitle, but just like the casual thing I wrote at the side as like a lambda, right? Because it's like, well, Solna is made of W waves. They're not measured with just regular lambda, right? It has its own thing, and it's represented by that symbol, right? That's just what I've decided. I think that's pretty appropriate too. It's pretty easy to draw, and it doesn't have any use for anything other than this, right? I was trying to decide that earlier too, but I think that's fine. Because I can't imagine anything else I would possibly use that for. Yeah, whatever. So with that aside, that's the unit that it follows. And I kind of like that too, that it's applied to Solnet. So let's see, what else? Oh, so how do we represent the 4 trailing, do they call them digits or places? Oh, places. The 4 places after the decimal point are supposed to represent the y and the x-axis. I don't want to make it too long because I don't want to overwhelm fans. So I'm like, okay, that's why I had the idea of using hex, right? That way I could represent, say, the first 2 places can go up to F, or F and F. And so you'd get 256 units one way, right? But then you'd have something that's extremely small. That's the only problem. That's why it's tough. I wanted it to be laid out as is. Like with 4 places in front of the decimal for 1,000. But let's say, oh, well, I can't make anything that's bigger than, I guess it'd be 99 if you were to just have it be not hex and just decimal. Then the max you can go is like 9 in one place, right? But you don't get very far with that. If you have the 2 places after the decimal just be 9 and 9, and then the 3rd and 4th places are also 9 and 9, you get something even smaller. So I'm like, okay, with hex I can make it all F's. Then you get 256. But even I think that that's too small. Because Solnet, it is more Solnet. Okay, let's put it this way. The areas in Solnet are more wide than they are tall. That's why it's kind of tough. Then I was like, okay, well, you could almost just not think of this as 3D space, even though it is. You can't even think of it like a 2D array or 3D array either. Because it works the same way. It works the same way like this thing I have in front of me. And then it's like, well, if the space itself, like, it's not measured in lambda, if it's not using some kind of spatial system that already exists, which I'm kind of hesitant to doing, since I want it to be easy for people to understand, then how does it exist at all? This is why it's so complicated. What do we have? So I can see 12 minutes. Come on, bro. Well, okay, let's look at it this way. Because it's like, yes, if you were to represent the first 4 places in front of the decimal using decimal, right? Just 1 to 1,000, right? And everything after the decimal point would be hex. Yes, you have your X and Y that would be. Oh, this is why you should see it. This is why you should see me drawing it on the screen. You know what I might do to make this unique is that I might play the audio and just draw in reaction to it. That's what I might do. So let's go with that. What you're seeing is separate from me actually drawing it. So there you go. That way it makes sense, because I feel like just explaining this to someone is just garbage, right? But you have your F and your F. Well, okay, 256 and 256. It's a square, right? Well, really, it's just one giant vertical prism, whatever, right? We haven't decided how long one of those units actually is, because we've made our own, which I thought I gave this a name earlier, or I was just going to call it Wu, which is Chinese. It just means undefined and doesn't exist, right? Because the Hanzi doesn't exist, the character. But that might change. but let's just call it unit for now, right? We haven't decided how long those units actually are. And I don't want to just use metric, right? Because I feel like, well, metric's way too small. Light years are also that's also pretty absurd. Because even like, isn't 4 light years even a lot too? Yeah, that's too long. So, okay. So it's just some other kind of unit then. Oh, aren't there like yards in Imperial too? How long is a yard? Yard. Imperial measurements. Let's see. Is equal to almost 1 meter. Huh. I'm sorry, but why does this even exist? Who even cares about this? But let's see. So how long would these units be then? Because yeah, I could just make something up. Like say, oh, one of these units is equal to about 7 meters. Let's look at it this way. I actually wanted the X and Y axis to be roughly the size of Wyoming in the United States, of all reasons, of all places, of all whatever. And that, I think it said it was like 280 miles. 280 miles by 380. Okay, I need to convert that because I don't know how long. Let's see. $611 kilometers. So 611, and what is 280? 450. I want it to be roughly this. Now I'm confused. So I have my dimensions for my X. Oh, well, I mean, they'll have to be the same number, right? So wait, what? I'm confused. Okay, wait. Okay. Wait, let's break it down, right? If we have, and I'm not going over, right? If we have our measurement, our F and our F are 256. Oh, then you literally just have to do some math here, because it's like, okay, well, let's go with the 611 first. And you would divide that. No, wait. As soon as I graduate, it just all the information is just gone. How do you wait? Am I doing I'm doing the right thing, right? FF 256. If that 256 is supposed to equal that 11. Then your X would go here. And then what would go over this? Or no, wouldn't this be a 1? And then okay, yeah, that's what I thought. So where's my calculator? Here it is. You would just divide 611 by 256, and that would mean that your units are roughly 2.4 kilometers. I think that's what that's saying. Because that's saying that's One of these is 2.4 kilometers. Which, that would be appropriate. I like that too. That's plenty of space. So I think that's what we go with. Because that would mean if you tune to a certain frequency, say, I don't know, 600.12, make it very easy, right? Then, okay, so yeah, 0.12, 0.13, 0.14, then your spawn points are in grids. I actually like the idea, because if you consider Injera knowing and just kind of camping the area where he knows that the XCT servers are, and that they're in grids, you're able to draw a map off of that. I think this is
Future of sidekicks.
That's enough!
Fighting! Fighting!
Ha! The future is ours to decide. Take this!
You okay?
Alright, I'll be in.
Ricky's one, two,
Right here!
Stream
edge!
Wonderful to be with everyone.
Is Ricky so handsome?
Wake up!
We can definitely do this!
Do it! You okay?
Head
Ricky, Ricky!
spinning.
Gotta concentrate. Gotta focus.
Yeah, I'm not quitting yet!
Ricky getting hungry.
Take this!
Ricky, Ricky!
Head spinning.
Everything's gone blurry. Wake up!
Head. Ha! S-Lash!
I can do it! I know I can!
I see it. I can change the future. I'll smash you up!
I'm feeling pretty good. Feel to have fun. Ricky want fun too. Fighting! Fighting!
Sorry.
Ricky!
Let's keep up the pressure! We haven't lost yet!
Feel upon Do it!
Thanks!
Cheer up, Fiora! Sorry, this isn't like me. Crush! Hold still!
Ricky!
Don't worry about it. Ricky's very happy. You okay? Everything.
We can definitely do this! Backslash!
Wake up!
S-Lash!
You wouldn't want to let us down now,
Stream
would you?
edge!
Wakey, wakey!
Where am I?
Yeah, Ricky's happy! No fun dance, make happy! Ricky protect future of sidekicks!